Knox County Summer Learners. My name is Miss Edens, and I teach 5th grade in the Knox County school system. This is the Science Grade 5 Activity 4 Summer Learning video. Activities and handouts that accompany this video can be found under the Student Resources tab on the Knox County Schools website at www.knoxschools.org. After completing this activity, we would love for you to show us what you learned. Tweet at KCS Science. If this video is hard to understand, there are a few things that you can do that may help. First, turn on closed captions if available. Second, you can adjust the playback speed to slow down the video. Third, consider watching short clips, then pause, listen, and watch again. And fourth, ask someone in your home to watch the video with you. Stop frequently and talk to your partner about what you heard and understood. Let's begin with Activity 1. Look at the black and white image on your screen and in your packet. Focus on the movement in the image. Now, this isn't a video, so you will have to use your imagination. There are a few objects in this image. I want you to focus on the round object labeled Object A. Imagine the movement that will result when this person strikes or hits Object A. Where will Object A go? Add arrows to your paper to show the movement of Object A. Will Object A stop moving? Add that detail as well. Be sure to pause the video to add your details. Now let's resume the video and we'll compare your picture to my picture. How did your picture compare to mine? Did you draw your arrows in a different direction? I bet your picture looks a lot like mine. I wonder why. Why wouldn't I draw Object A moving immediately downward? What makes it move upward and then down? And how did you know that it would move that way? How did you know Object A would stop? It's gravity. Is this force such a mystery if you knew it would cause the ball to move that way? Let's look at how vocabulary defines gravity.
We're broadcasting live from the first interplanetary dunk contest. We've got all of your favorite dunks coming up, but first, let's learn what gravity is.
Gravity is in effect, always, forever. Gravity is a force that pulls objects together. Earth's gravity pulls us all down. If you trip, gravity makes you fall to the ground. If you let go of a ball, gravity makes it drop. When a graduate throws a cap, gravity makes it stop, and it's gonna keep falling until it hits the ground. You can jump up, but gravity brings you down. Everybody jump! You'll come back down. Every time you jump, you'll land back on the ground. Gravity pulls you towards the earth with a force, and it's why the planets all stick together on course. Everybody jump! You'll come back down. Every time you jump, you'll land back on the ground. Gravity pulls you towards the earth with a force, and it's why the planets all stick together on course.
All right, our first competitor is Isaac Newton Jr. Let's see how he does on planet Earth. Here he comes. Oh, off the front of the rim. Not quite high enough. Now let's see him jump on the moon. Here he comes. Boom, shakalaka. Here's his third try. This time on planet Jupiter. Oh, and he can barely get off the ground.
Do you wish you could jump with a basketball and land a slam dunk? Well, if you can't on Earth, try it on the moon. There's less gravity. You jump higher like zoom. But on Jupiter, even LeBron couldn't dunk because the gravity there is too strong. Jupiter is heavier. It has more mass. Mass is the amount of matter that something has. It's like how much it weighs. So naturally, the more mass that it has, the more gravity. So the sun has more than Jupiter, and Jupiter's got more than the Earth, which has more than the moon. But don't stop. The moon has more mass than you. Yes, everything has some gravity. That's true. A ball has gravity, but the Earth has more. That's why what you throw will soon fall to the floor.
So that's why that happens.
But if you threw it on the moon, it would go much further than you probably would assume. Or if you threw it from a spaceship, it might go forever, so there's no need to chase it. Everybody jump, you'll come back down. Every time you jump, you'll land back on the ground. Gravity pulls you towards the Earth with a force, and it's why the planets all stick together on course. Everybody jump, you'll come back down. Every time you jump, you'll land back on the ground. Gravity pulls you towards the Earth with a force, and it's why the planets all stick together on course.
And that's all the action we have for today, folks. Thanks for tuning in to the very first interplanetary dunk contest. Be sure to tune in next week where we play internebular dodgeball in a black hole. Good night.
Wow, we can now easily define gravity as a force that pulls two objects together. In activity 1, the two objects being pulled together were the baseball and the earth. According to the video, all matter has gravity. Since the baseball is made of matter and the earth is made of matter, they must both have gravity. I wonder which one has more gravity. Remember in the video when LeBron tried to dunk the basketball on Jupiter? Why did he have trouble? The gravity was way too strong because the mass of Jupiter is so much greater than the mass of Earth. That must mean that more mass means more gravity. Take a look at this model of our solar system. You can see how much bigger Jupiter is than Earth in this model. It makes sense that it will have more mass and gravity. Now, do you think Jupiter or the Sun, which is over there on the left, has more gravity? Just think about which one of those is larger. Now let's practice. All matter has gravity, even if you can't feel the pull of that gravity. Since all matter has some gravity, you can look around your house and figure out which things have more gravity than others. Would a pencil or an apple have more gravity? Well, the apple, of course, because the apple has more mass. What about a car versus this cute puppy? The car has much more mass, so the car has more gravity. Now, what about distance or how far away something is from another item? How does that affect the pull of gravity? For this activity, you will need a tennis ball, string, and some cloth. Now, I didn't have a tennis ball because my dog, well, took off with my tennis ball. So I have this foam kind of ball. It's the same size as a tennis ball. This is what I had at my house. You also need some string, and what I had at my house, I had some yarn, and the length you need is 1.5 meters. So I took my string and I pulled it out to about the length of my arms outstretched. And the cloth should be about a foot square. That will work. The first thing you will do is you will wrap your cloth around the ball. And this is very easy to do. All you have to do is place the ball in the middle of your cloth. And if you take the corners to the corners of your cloth and you pull them up, tie those two corners down like this, and then you take your other two corners you can tie those just like this. You have a little pocket. Then you securely tie the string to the cloth at the knot. So the easiest way to do this is you take your last two ends, take an end of your string, place it over, and tie your knot. When you're done, you will have a cloth covered ball at the end of your string, just like this. Now, the next part, very important. You must stand far away from other people. You don't want to hurt yourself, and you don't want to hurt other people. Also, it's best to do this outside if at all possible, because you don't want to hurt anything inside your house. You are going to be slowly spinning the ball in a circle. So you will hold the other end of your string and you will begin spinning the ball around in a circle. Now, there's no need for you to do the spinning. You just simply stand in one place and you spin the ball around in a circle. If you do the spinning, you will get dizzy and fall down. We don't want that happening. Now, after you have had a chance to spin it around several times, you will finally let go of the string. Be sure nobody is in the way when you do this. I will let you do this part of the activity. Pause the video for a few moments while you do this part of the activity. What happened when you let go of the string? Did the ball fall straight to the ground? Where did the ball go? Now, I want you to think about our solar system. The Earth moves in a path around the sun, and it's held in its place by gravity and something called inertia. Now, inertia holds it in that orbit along with the gravity, and it causes the Earth to follow this path. I want you to imagine what would happen if the solar system had no gravity holding the Earth or the other planets in their orbits. As the ball got farther away from you, did you have more or less control over it? Gravity is just like that. As the distance between objects increases or something gets farther away, the gravitational pull is less and less. If you were an astronaut, you wouldn't want to get too far away from the gravitational pull of the planet you were exploring, would you? What would happen? In conclusion, the more mass an object has, the more gravity it has. The farther away two objects are, the less gravitational pull they will have with one another. I would like to leave you with a wonderful historic video which was taken during the Apollo 17 moon landing mission in December 1972. Which of the concepts we talked about today do you see illustrated in this video?
I was strolling on the moon one day in a merry, merry month of December. May, when much to my surprise, a pair of bunny eyes. Boy, is this a neat way to travel. Isn't it great? Dum-da-dum-dum-dum. Dum-da-dum-dum-dum.
I'd like to give a shout out to all my fabulous students at Farragut Intermediate School. I miss you guys like crazy. Go Edens Explorers.